Okay, everyone, so I'm going to continue where I left off the last time in the last video, and um, just looking at the fourth quadrant. Okay, talked about the first, so Q1, Q2, Q3. Okay, so we've looked at the reference angles for those three quadrants, and then in the fourth quadrant, Q4, if we have an angle in the fourth quadrant, again, angle is formed by the initial side, which is always on the positive x-axis, right, centered at the origin, and the terminal side, which is in the quadrant, right? So this is a fourth quadrant angle, Q4. So we are looking at this angle, always counterclockwise from the x-axis, okay? And it's positive. Counterclockwise is positive, clockwise is negative. So this angle right here, that's our theta, okay? And that's a fourth quadrant angle. So if this is theta, then we know that this has to be our reference angle in here. Why? Because reference angles are always formed by the terminal side and the x-axis. And it's acute, right? So it's an acute angle, which is less than 90, formed by the x-axis and the terminal side. So how do I find this reference angle if I know what theta is? Well, if theta, let's say, in the fourth quadrant, let's say I have an angle that's 330 degrees. Okay, so 330. So actually, let me just color coordinate it. So let's say my angle, my theta, is 330 degrees. That's definitely in the fourth quadrant because I know this is 270 and this is 360, correct? So it's got to be somewhere between 270 and 360. Then my reference angle, okay, it's going to be whatever additional measure I need in order to get to 360, which means that I could take 360 and subtract 330 from it to get my reference angle, which in this case would be 30 degrees, correct? So that is a 30-degree reference angle in the fourth quadrant. Okay, guys? So let me just kind of review the whole thing for you. So let me just clear the board. So just kind of in review, okay, if I have my x and here's my y, right? In the first quadrant, there's no reference angle because the theta is the reference angle, okay, if you want to call it that way. Why? Because it's an angle formed by the terminal side and the positive x-axis, which is acute, correct? And let me see here. In the second quadrant, if I have an angle, that stops at the second quadrant, then I know that my reference angle, again, is sitting right here. All right, because why? Again, it has to be formed by the terminal side and the x-axis, and it's got to be acute. If I look at the third quadrant, my reference angle is going to be right here, correct? Because again, it has to be formed by the terminal side and the x-axis, and it has to be acute, less than 90. And then finally in the fourth quadrant, I'm running out of colors here. Let me use black. So my reference angle in the fourth quadrant is going to be right here. Okay? Because again, formed by the positive formed by the x-axis and the terminal side, and it's acute. All right? So now what I'm going to do is I'm going to put them together. Highlight it and put them together. So using one color. So if I put all the reference angles together, like so, then what I have looks like a bow tie. Okay, So basically, reference angles can also be referred to as bow tie angles, because when you put them all together, it looks like you formed a bow tie. Okay, guys? All right. So now, knowing this, how can it help me to find what I originally wanted to find, which was this question? How do I find the cosine and sine of 240 degrees? Well, this is how you do it. So let's say I want to find 240. Well, 240, again, let me give you the angles here. So this is 0, this is 90, this is 180. Okay, these are all degrees, by the way. This is 270, and then this is back to 360, correct? Now, 240 is going to be here, correct? It's going to be a Q3 angle. So let's say this angle here, let's say this complete angle here is 240. Which means what will be the reference angle for 240, which is a Q3 angle, correct? It's in the third quadrant. So our 240 degree angle stops right here. Okay, so then what will be the reference angle? Well, the reference angle is, remember, it goes beyond 180, right? So 240, to find this angle in here, you would have to take 240 and subtract 180, correct? So 240 minus 180, and that gives you, I believe, 60, correct? So the reference angle here is 60 degrees. All right? Well, I already showed you how to find sine and cosine of 60, didn't I? Using that little table. So if you remember, sine of 60 degrees is equal to radical 3 over 2, and the cosine of 60 degrees is equal to 1/2. Okay, and just check your table. Remember that I presented to you in the second video. Okay, so we have the values of sine of 60 and cosine of 60, but this is not 60, it's 240, correct? They're looking for what's cosine and sine of 240. These are the reference angles here for 240. But what's sine of 240? And what's cosine of 240? Well, remember, in the third quadrant, your x-coordinates are negative, right? And your y-coordinates are also negative. Everything's negative. Remember, sine is y and cosine is x. So in the third quadrant, sines and cosines are all negative. So the values are the same because we used the reference angle of 60, right? But the signs, the pluses and minuses, are going to both be negative because x's and y's are all negative. So here's your answer. Okay? And there is your values of sine of 240 and cosine of 240. Okay, so let's plug them in. So they want the cosine of 240 first, which is going to be negative 1/2. So it's going to be negative 1 over 2. And the sine of 240 is negative square root of 3 divided by 2. Okay, let's check. And that is correct, okay? Let's do the last one here. Now, this is in radians, correct? So again, we can convert the degrees to radians, right? So if we convert it, let's do a quick conversion. Let me clear the board again. And we have 2 pi over 3, right? So what is 2 pi over 3? So using the conversion, 2 pi over 3, and saying we're converting from radians to degrees, correct? So remember, we have to multiply this by 180 over pi, correct? If we do that, switch back to the original here. There we go. So if we do that, we're going to have the pi's canceling out, right? Pi over pi. You can cross cancel, right, across the multiplication. So pi over pi is 1, and then 3 goes into 180 60 times. So 2 pi over 3 is really 2 times 60 was 120 degrees. Okay, so you can work with 120 degrees. Let's do that. So where is 120 degrees? Again, draw a little sketch. Okay, here's our x, and here's our y. And here is, this is 0, right? This is 90. This is 180. This is 270. And then we're back to 360 again, correct? So one full circle. So 120 is between 90 and 180. Does everyone agree? Okay, so our angle is somewhere, let's say in here, like that. Okay, again, formed by the positive x-axis and the terminal side, right? Initial side and then terminal side, like so. This is 120 degrees right in here. This is, okay, this is theta is equal to 120. So if theta is equal to 120, if we're now in the second quadrant, then to find our reference angle, we would have to do what? We would have to take 180 and subtract theta. So 180 minus theta. Theta is 120, so 180 minus 120 is equal to 60 degrees again. So our reference angle here again is 60 degrees. And again, using the values that we found in our table, right? Let's find what's sine of 60 and cosine of 60 again? We just did it, right? So sine of 60 was radical 3 over 2, and cosine of 60 was 1/2. Okay, but since now we're in the third quadrant, we know that in the third quadrant, okay, in Q3, we know that the x values are negative, but now the y values are positive, correct? If we're writing here, any point that's in here, the x's are negative, but the y's are positive. So we know that sine is the y, and cosine is the x. So therefore we know that cosine has to be negative 1/2, and sine has to be positive 3/2. So there are our answers. Okay, so let's plug them in. The sine is positive 3/2, is positive 3/2, and the cosine is negative 1/2. Just quickly check. Yes. And let's see. That is correct. Okay, guys? All right. Take care.